This is the part of correlation and regression that students hate, because you have to interpret using actual words, not symbols, which as mathematicians we don't really like, but it's important. This is really important, that you have to use the actual words in the right order to form the correct sentence. You can't just vaguely answer the question. You have to memorise the structure of the answer and give the exact right words in the right order. So this is the most common answer from students if they get this question. So we've got a set of data, and to see if there's a link between the temperature of the air, that's on the x-axis, and the number of people on the beach in thousands, and we've got a PMCC of 0.72. So that means that our scatter diagram looks something like this, and that the line of best fit has a positive gradient, and it's quite a strong correlation. The crosses of the scatter diagram are quite close to the line, and this is a good answer. 0.72 for a PMCC does tell us that we have a quite strong positive correlation, but we need to see a bit more than that. So this is what we also need to see. We need to say the sentence that or describe what correlation is, basically. So a positive correlation means that as this variable x goes up, this variable y also goes up, but we need to use words. So in this question, as the temperature, I already said as the temperature increases, the number of people on the beach also increases. So the full marks would be for realising that 0.72 gives you a positive correlation, and realising that since the biggest it can be is 1, that's actually quite a strong correlation. But then we also definitely need this sentence. As the thing on the x-axis, temperature, increases, the thing on the y-axis, number of people on the beach, also increases. Still with the same example here, now we're looking at the regression line. Say we've calculated the regression line, y equals 4.03.3.27x. So the b, the gradient, is 3.27. So a common answer to the question, interpret the value of 3.27, is for students to say it's the gradient of the line. And that is true, but it's not what they're after. What they're after is for you to understand what a gradient is. So a gradient of a line means that if you go across one, you go up by the gradient, which we usually call m. So what we're saying is, if we increase the x, whatever it is, by 1, then we will increase, in this case, because it's a positive gradient, increase the y by 3.27. In words, it would look like this. So what we've got is that we're saying that as we increase x by 1, and x here is the temperature, so for every increase of 1 degree centigrade, notice I'm using the units there as well, not just 1 degree centigrade, the number of people on the beach, that's what the y-axis represents, increases, because the gradient of the line is positive, not negative, by 3.27, because that's the gradient. Okay, this is wrong, and it's the most common thing that students do wrong. Hopefully you've realised what's wrong. What's wrong is that the y-axis doesn't represent the number of people on the beach. It represents the number of people on the beach in thousands, and you always have to have a look up and see what the units were. Like here, I said I've used the unit, degrees centigrade. The unit for the y-axis is thousands of people. So for every increase of 1 degree centigrade, the number of people on the beach doesn't increase by 3.27, it increases by 3,270. Final thing that you could be asked to interpret is the value of a in the regression line. So that's the bit at the beginning here, 4.03. Same thing with the temperature and the people going to the beach. So 4.03 is the equivalent of what we would normally call plus c, it's the y-intercept. Now this regression line that I've drawn on, it doesn't really exist outside of the data set. You can't extrapolate that the line would carry on outside that data set. But if it did, and this is how we could plot the line, then it would go through the point 4.03. So the y-intercept is 4.03, that's true. But, same as the previous thing, what we need is an interpretation of that in the context of the question using words. So what we want is something more like this. So what we're saying is, when the y-intercept is when x is 0, x is the temperature. So when the temperature is 0, when x is 0, so on the y-axis, when the temperature is 0, we would expect, and then 4.03 obviously for y represents 4,030 people, because y is number of people in thousands. So we would expect that number of people to be on the beach. And this is extrapolation, this is called. Sorry, extrapolate. We're extrapolating past the data set. So here's the original set of data. These are the temperatures that we took the temperature, measured the number of people on the beach. If we're between there and there, in terms of the temperature, then actually regression line is quite a good model. But if we're outside of that, our regression line, that's extrapolating outside the original set of data, and outside of that the regression line probably isn't a very good model at all. So this is an example of extrapolation, but it is the correct interpretation of 4.03. It tells us that when the temperature is 0, we would expect 4,030 people to be on the beach. But that is extrapolation, really. Okay, have a go yourself. So we've got some new data to see whether there's a link between the age of a car and its value. Obviously there would be a link. We've calculated the PMCC and the regression line, and you're asked to give an interpretation of the three figures, the minus 0.69 for the PMCC, 1.20 for the A value, and minus 0.534 for the B value. See if you can write down what you think the answers would be, and then I'll show you. So here's the answers. The PMCC is minus 0.69. That's quite strong because it's near minus 1, and it's obviously negative correlation because it's negative. But the words we want to write are, as the age of the car increases, its value decreases. That's the sentence we want. As this thing increases, this thing decreases. So the regression line is y equals 1.20 minus 0.534x. The 1.2, that's interpreted as basically the y-intercept, which is when x is 0. So we're talking about the car being aged 0 years, so it's new, and that would give us a value of £1,200 for the car. Remembering that y is the value in thousands of pounds, so 1.20 times 1,000. And the minus 0.53, the gradient, a gradient means for every 1 across, that's what you go up or down. So in this case, 1 across is the car aging by 1 year. So for every 1 year that the car ages, and then gradient is how much, sorry, I've just got totally distracted because I put an apostrophe there, which shouldn't be there. There we go, I'm happy now. So for every 1 year that the car ages, its value decreases because the gradient's going down. So the regression line would look like this. The value decreases by £534, not 0.534, because it's in thousands of pounds, so you times it by 1,000.